Assalamualaikum and good day everyone. Today our group will be conducting an experiment about Lenz law. Who came up with this law? Of course the man in the name itself, a physicist named Emil Lenz. According to Lenz, the polarity of the induced voltage such that the voltage would produce a current that opposes the changes in flux linkages responsible for inducing the EMF. The direction of this current flow could be determined by applying right-hand thumb rule. The thumb indicates the north pole. The finger's claw indicates the direction of the current flow. Now, I would like my fellow group mates to explain even further with demonstration about Lenz law.
Assalamualaikum and good afternoon to all. My name is Muhammad Fazril. Today I would like to tell 3 advantages of electromagnetic induction, which is Lenz law. First of all, AC or DC electrical power can be generated by using the electromagnetic energy source. Second one is it can eliminate the need of another external electrical source to generate electrical power. Third one is it can also apply to electrical generator. When a current is induced in generator, it will cause the rotation of generator, and also it will provide a back EMF in case of electrical motor. Thank you.
I'd like to show you guys how to conduct a very simple experiment in which every one of you can do. It calls jumping coil experiment. So what we're going to need is just a battery here, a magnet, and I'm going to use a stack of them because this is just a weak magnet, and then copper coil. This is just 0.2 millimeter size. So how we're going to do is we're going to wrap a coil and make it a coil like this, like 5 number of 10 coils, just a very light coil so that it can jump, right? And then we're going to clean and remove the insulator from the coil. Just use a normal knife, right? Okay, just please be careful with this. Just going to remove this side, which is the insulator layer, just on the right, and then we're going to connect one end of the coil to the battery, just like this, right? Okay, make sure this connected, so carefully, right? And then we're going to take another end, which is the other end, to touch on the positive terminal of the battery. So as you can see, it moving, it is jumping actually, right? And then if I reverse the polarity of the battery and connect it again carefully, right, it's going to go, it's going to, it actually goes to the other way around, right? Right, I'm going to put it so it's going to the other way around. Okay.
So, let's get to know about the theory behind this experiment. As we know, a wire that carries current have a magnetic field around it. In this experiment, the wire is turned into a coil, and where the magnetic field is concentrated, producing a static magnetic field around itself, forming the shape of a bar magnet, giving a distinct north and south pole. Okay, to determine the direction of magnetic field, is based on the direction of current by using right-hand grip rule. The direction of the current itself is based on the polarity of the battery, where the current flows from positive terminal to negative terminal. As we can see in the video, the north pole of the coil is pointing downward. In the first case, the coil is jumping upward. It is because the bottom part of the coil is north pole, and it meets the north pole of the permanent magnet. So this pole repels between each other, causing the coil to jump upward. In the second case, where we turn the magnet upside down, the coil is pulling downward. Why? It is because the bottom of the coil now meets the south pole of permanent magnet. So the pole is attracted to each other, causing the coil to pull downward.
So, as we have seen, with electromagnets we can do many things, and it has been used for various purposes on a daily basis, such as an electric fan and electric doorbell. In an electric fan, the electromagnetic induction keeps the motor rotating on and on, making the blade of the fan to rotate. Also, in an electric doorbell, when the button is pressed due to the electromagnetic forces, the coil gets energized and the bell sounds. And that's all from our group. If you like our video, don't forget to thumbs up and leave your comments down below.